Hello, my name is Nick Pragakis. Today, I'm going to be doing my paper review. The title of this paper is Modulated Detection for End-to-End Multimodal Understanding. So let's get into it. So a bit of an overview. This paper was released in April, so just a couple weeks ago, by Jan LeCun and his team of researchers at NYU and Facebook AI Research. So for those who don't know, Jan LeCun was the original founder of the convolutional neural net back in the early 90s when he was working for AT&T. So pretty big in our community. So let's get into the paper and what this is all about. So first of all, what are multimodal understanding systems? So it's basically just a big fancy word for machine learning models, typically deep learning neural net models that are going to aggregate multiple sources of data. So these models are going to be taking in images, text, videos, all to complete one common downstream task. So in this particular example, this model is trained to take in text, which could be an image or a caption or question regarding the image, and then the actual image itself. So essentially what we're left here is a text conditioned object detection pipeline on images. So you can look in the top right and see some of these pictures just to kind of get a feel for what this model is doing. So here in the top, we have a Q&A. So, we're asking the model what is on the table. So you can see it's able to perform object detection to identify the table and the what from the question. And then you can see the predicted answer laptop. So doing a great job. So what makes this model different than a standard object detection pipeline? So if we look here at this image on the left, this is a standard object detection output for a model. So you're going to get these bounding boxes with the predictions of what that class is across every possible object in the scene. So that's great, but we're able to do a lot better when we're including the text involved. So you can see, when we switch over to this multimodal object detection, our input query here was highlighted: blonde boy wearing blue shorts, a black surfboard. So you can see instead of getting this mess of just a lot of noise, there's looks like 10 or 20 different bounding boxes. You don't really know what's going on in the scene. By giving this model this, input caption of what we're interested in, we're able to just get the most important stuff based off our query. So we have the blonde boy, we have the black surfboard, and we have the blue shorts, but we don't have any of the other noise. So that's kind of some of the benefits that you get when you're able to incorporate multiple streams of data, such as the image and the text in this case. So this is kind of a bit of a summary on the model. Quick sidebar here, for those who still haven't done their projects for paper reviews, I highly recommend the website paperswithcode.com, as you're able to not only read the paper but see the source code as to how this stuff is performed and run through some tutorials. So moving on to the details here. So we'll start with the data set. So this model was originally trained, pre-trained on modulation detection. So what that is that's just going to be the bounding boxes essentially. So, the initial warm-up for this training was conducted on a data set of about 1.3 million images with bounding boxes and the associated freeform text captions. And these data sets were the Flickr 30K and MS Coco. So in the bottom right here, we've got this man wearing a hat. This is a sample of the Flickr 30K data set. So essentially we're just left with a bunch of captions related to the image that are color-coded by the bounding box. And this allows our model to, associate each token of the text with what's actually going on in the image. So this was the pre-training. MS Coco is going to be, similar to the Coco data set, which is, the industry standard for object detection and this bounding box stuff, but just with overlaid captions similar to this. So this is how the model's initialized. It goes through this training on these images and builds up a solid learning base before we do some more task-specific training. So what that task-specific training looks like is we're fine-tuning on the Clever data set. So the Clever data set's another benchmark for vision and language reasoning on objects. So We've got a couple examples here with these blocks and these down here. So these are synthetically generated queries and images that essentially just ask, details about the shapes, colors, locations of these objects in a text format, and the model's got an image or reason from the image and the text combined to output the answer. So this was the general pipeline of this model. So just a quick recap: we pre-trained on the Flickr 30K, the more realistic human scene images, and then fine-tuning on a number of these clever variations. So clever being these the shapes and the reasoning that goes along with the location, color, modality of the shapes. So that's a bit on the training set. Let's go a bit into the model and some of the results we found. So as I mentioned, the multimodal means you're taking in these different sources of data. So in our case, we have the images and we have the text. So in order to do that, we have a model that consists of essentially two input heads. So our first one, as you see in the bottom diagram, is going to be just a standard convolutional neural net. So in our case here, this was a ResNet 18 pre-trained on ImageNet. What's really nice about this paper is that they, give a lot of details as far as where they got the models and where they're pre-trained. So as you know, in this era, we're able to get a lot of really great pre-trained models to do transfer learning on. So they link, the exact model that ResNet 18 that was, the base for this model. So it's available in PyTorch. You can just go ahead and use it right out the box right now if you want it. So that's how we handle the images. The text is a Roberta language transformer model. And once again, this is, very well documented as far as where they got it. This is just their standard Distill Roberta pre-trained transformer model from the Hugging Face library. If you're interested in that, you can check out the paper and get more information on that. So the results of these two input layers, once they are, once the data passes through them, are then combined, as you see here in this concat function, and then passed to another transformer. So you can think of this as kind of, we're taking this image and we're taking the text, we're running it through, the specific models needed for that. We're encoding that, and then we're decoding it. And the output of the decoding is going to be, what we look at here with the bounding boxes on the images and our overall predictions. So as you can see, the results, this model beats 8 out of the total 11 benchmarks that we have for this clever data set, as well as a couple of other data sets. So it's really state-of-the-art model here. Quick summary of some of the findings and learnings. One thing is that this multimodal way of learning has a really great feature of, giving increased generalization capabilities and substantially improving the zero-shot performance. So that means we can stick this model out on the internet. Somebody can come and download it and use it for their task. And the zero-shot settings, meaning there's no training involved, are very good with respect to everything else that's out there. So this really actually sort of democratized the AI development, as these open source models are able to be used by anyone who has an internet connection, and really moves the industry forward. So I think this multimodal learning is a key area of future research. Human learning is not conducted in these silos of just text or just image. It's really combining all of the senses. So I think this is a great first step into getting into that area with our machine learning models. So finally, you can see some of the examples of some outputs here. What's the color of the train? We see the train boxed, and then this is just identifying the lamps in the room. So that's it. Thank you.